Hi, we have the AP Physics 1 past paper 2019. We are discussing the section free response questions. Now, question number 4, which carry the 7 points. In the question, a motor is a device that, when connected with the battery, convert electrical energy into mechanical energy. The motor shown is above is used to lift a block of mass m and the constant speed from the ground to the height h above the ground in time interval delta t. The motor has constant resistance, is connected in series and with the resistor R1 and the battery as shown in the figure, it has the series path. The mechanical power, the rate at which mechanical work is done on a block, increases if the potential difference or voltage drop between the two terminals of the motor increases. Mean mechanical work or mechanical power is increased when the potential drop across the motor is increased. That's the info is given. Okay. Now determine the expression for the mechanical power in term of m h delta t. H is a height, m is a mass of block, and delta t is a time interval. Okay, the block is lift vertically. So with lift vertically and with the constant speed, is constant speed indicated that there is no change in velocity. That's mean there is no change in kinetic energy. So the whole work done by the motor is equal to in the gravitational potential energy. From this info, we can say there is no involvement of kinetic energy. There is a whole work done is converted into gravitational potential energy. So power is the work done divided by time. Work done is can be represented now delta U time delta T. Delta U or change in gravitational potential energy can be indicated by mgh over delta T. So that the here should be capital M for the mass of the block, H for the height of the block, time is the time interval for that. Okay, that's the answer. Now, the next part, without M or H being changed, the time interval can be decreased by adding one resistor R2, where R2 is greater than R1. The circuit is shown above. How would the resistor R2 be added to the circuit to decrease delta T? So, if we say what happened if we decrease the delta T is increased, then it's mean the power is increased inversely proportional because m is constant, g is constant, h is constant. So power is inversely related to time. So there is a multiple option in parallel with the battery, in parallel with the R1, in parallel with the motor, in series with the battery R1 and the motor. So we have to see what is the most reasonable option we have. In clear, coherent paragraph, length response may contain the figure and equation. Justify your selection would be decrease delta t. Okay, answer is in parallel with R1. So why that this is answer? We have the justification. Faster the rate of energy transfer mean work done is smaller interval of time. As we say here, delta t is smaller, power is greater. Power is mean greater mean there is a more work done or work done in smaller interval of time. Okay. Now, to decrease the delta T, we must increase the power. So, to increase the power, more voltage should be required across the motor. This information is provided here that if we want to increase the power, we have to increase the potential difference across the motor. Okay. Then from fig, we can see battery provides the fixed potential, fixed voltage. This voltage is shared between the resistor and the motor. So the voltage provided by the battery, you can be used R1 and the motor. The voltage across the motor depend upon the external new resistor, how we are going to connect. Let if R2 is connected across R1, mean in parallel combination, their equivalent resistance would be decreased. Because we know that two resistance in parallel give always equivalent resistance smaller than the smallest individual resistance. Mean their total resistance would be less than R1 now in this case. So what happens if the equivalent resistance decreases? The potential difference across the parallel resistors will be decreases because the overall resistance decreases. Their consumption of the energy will be decreased, so potential will be decreased. As a result, because the potential is shared by the battery, now resistor are using small potential difference, so there will be more potential available for the motor. So that's the represent. As a result, there is increase the potential difference across the motor, as we have seen there. So the mechanical, this increase the mechanical power and decrease delta T. So we have to place R2 in parallel with the R1 to get the decrease the delta time. That's the answer. If you have any query, kindly ask in a comment. If you like the content, kindly subscribe and share with your friends. Okay, take care.